So lesson 1.1.3. Now we're talking about part 2, tile pattern number 2. So complete parts A through D below. Be prepared to present again your work to the class. In this case, you guys are just going to share it on Edpuzzle. Put your pencil down, quietly study the tile figures in tile pattern 2. In your mind, think about how you would draw figure 4 for tile pattern 2. How would you draw figure 0 for tile pattern 2? For each function, complete the tile figures, table, and graph on your resource page or on your notebook. And then on your notebook, describe how the number of tiles grows from figure to figure for each function. And then finally, describe the graph of the function. Consider again, what is the general shape of the graph? From left to right, is it increasing or decreasing? If you drew a line or curve through the points and extended it through the graph in both directions, what would the x and the y-intercepts be? Are there any values of x or y which are not possible in the function? So let's study first the number of tiles that we have here. Now there is a tool that we'll be sharing with you guys that I didn't share in the previous part, but you can always use it. So we're looking at the E tool on Desmos. So here we want to study the pattern for tile pattern 2 with your team, right? Well, in this case, by yourself. So you have to do figure 0. And if you guys notice here, this figure 1 has 1, 2, 3, 4, 5. This one has 4 on the sides and then 4 in the middle. So that makes a total of 8. And then here we have figure 3, which has 9 in the middle and then 4 on the sides. So that means a total of 13. So we had 5, it looks like 8 now, and now we have 13. So it does look like we're going by a factor of 5. So we'll just try to figure, we're not exactly growing by a factor of 5, but it is different. If you guys notice, the square in the center is the one that keeps changing. And then the edges stay the same. So that's 4 right there. That's 4 right there. So let's try to do figure 4. So that means we're going to have a square of length 4 in the center. And then you guys can just drag these squares here. And then, okay. So let's drag 4. 1, 2, 3, 4. So square 4. Hopefully I have enough tiles for everything. Looks like I will. So that's a total of 16. And then 4 on the edges right there. So that means I would have a total of 16 plus the 4 edges makes it a total of 20. All right. And again, you guys can use this. So figure 1 has a total of 5. Figure 2 has a total of 8. Figure 3 has a total of 13. And then figure 4 has a total of 20. So now you guys should be able to see the graph right there starting to develop. And now you're missing figure 0. So what do you guys think would be figure 0? All right. So if you guys notice, one of the things that don't change is the 4 squares that are on the edge. And then this is the one that increases, right? Depending on the figure number. So here, figure 0 in this case would be just, let's see if we can draw it. So that's 1, 2. There should be nothing in the middle. So therefore, I'm only going to have 4 squares in total. To move 1 from over there, but it's okay. So here we're going to say 4 squares in total. And if you notice, that continues a pattern on the line. And then the final one, right? If you notice again, the square in the middle, depending on the figure side, is the same thing. So here, if we want to look at figure 5, which is the last one, we square 5, which would be 5 times 5 is 25. And then we add the initial value or the figure 0 number, which is 4. So that gives us a total of 29. And if you guys notice, you already have the rule. It's already on the notes, right? So if you guys look back in the notes, the rule should be right there. So The equation is also known as the rule, okay? So be careful with that. So the equation here is y equals x squared plus 4. So let's type it in. Y equals x squared plus 4. Not that one, okay. So if you guys notice, it matches pretty much the same path that I had right here with the other graph. And now let's move on to describe the graph. So what is the general shape of the graph? If you guys notice here, it is a U shape. That shape is called a parabola. So that is a parabola or U shape. From left to right, is the graph increasing or decreasing? And from where we started, the graph is increasing, right? Because if we take out the rule, you'll notice that it is increasing from 0 to the right. So we can say the graph is increasing. So the graph is increasing started from 0 to the right. And then if you drew a line again, the x-intercepts, we can't see any x-intercepts, but we can notice that there is a y-intercept at 0, 4. So that's pretty much where our graph starts right there. And then on the next one is on 5, and the next one. So we said it was going to be 4, 5, 8, 13, 20, and then this is 28. I'm sorry, 29. 2 is 8, so 2 is 8 right there. 3 is 13. I think so, yeah. And then 4 is 16. Should be about right there. And then, I'm sorry, 4 is 20, not 16. 4 is 20. And then 5 would be the last one, which is 29. So it'd be right there. So again, if you notice, it follows the same path. It increases starting from 0, going on to the right. So again, the y-intercept is 0, 4. There are EX values which are not possible for the function. I don't see any. So in this case, there are none, right? So there are none.